what if I told you that even after centuries of study, Jupiter still has jaw-dropping secrets hiding beneath its swirling clouds? Hey everyone, welcome back to SpaceTube, and today we're using the James Webb Space Telescope's infrared supervision to crack open mysteries about the king of our solar system like never before. In the next few minutes, we'll reveal how Jupiter, yes, that familiar gas giant, actually sports faint rings, powers auroras more intense than anything on Earth, and hides a core almost as hot as the sun. Plus, you'll see brand new Webb images that expose shrinking storms and magnetic dances between Jupiter and its volcanic moon Io. Stick around, because by the end of this video, you'll never look at Jupiter or any planet the same way again. Ready to dive in? Let's go. Did you know Jupiter has rings just like Saturn? They're faint, but they're there. And believe it or not, Jupiter lights up with auroras at both poles, so bright and powerful that they generate up to 100 terawatts of power. To put that in perspective, that's more energy than 100,000 power plants combined could produce. Even stranger, some of Jupiter's moons have their own magnetic fields. And despite being so far from the sun, Jupiter's core is the second hottest in our solar system, right after the sun itself. No wonder back in the day people thought Jupiter was a failed star. Let's rewind and look at how we got here. Around August 5th, 2011, NASA launched the Juno probe to study Jupiter up close. It's now been 10 years since Juno left Earth, and even today some of Jupiter's deepest mysteries remain hidden. That's why NASA pointed other observatories like the Hubble Space Telescope and the Gemini Observatory on Earth toward Jupiter, and finally James Webb joined the party. Juno and Hubble probed Jupiter's surface in ultraviolet and visible wavelengths. Gemini not tried studying its atmosphere in infrared, but our own atmosphere limited how deep it could see. Webb, orbiting beyond Earth's atmosphere, can peer right through those clouds in infrared, revealing the heat signatures from deep down. Thanks to Webb, we now know that although Jupiter's upper atmosphere freezes over quickly, its core still burns at insanely high temperatures. So what's really going on inside Jupiter? Are the gases at its center crushed into liquid by pressure, or is there a solid core? Scientists are still sorting that out because understanding Jupiter's core thermodynamics could also explain how its never-ending storms like the Great Red Spot are powered. Speaking of storms, Jupiter's famous dark and light cloud bands race east and west at about 400 miles per hour. About 400 years ago, those opposing winds spun up the Great Red Spot in the southern hemisphere. A cyclone so massive it could swallow two Earths side by side. But now, only here, it's thousands of miles across. Check out this recent near-infrared image from Webb. Using 3 different filters, it unlocks layers of Jupiter's atmosphere. 1. Red filter. Highlights the upper haze layers, clouds of ammonia ice crystals, along with glowing auroras right at the poles. 2. Middle filter. Picks up heat from deeper clouds of hydrogen and helium. 3. Blue filter. Traces methane-rich regions closer to the core's influence. And those auroras, unlike Earth's which are triggered by the sun, are fueled by 3 of Jupiter's closest moons, Io, Europa, and Ganymede. They orbit in a 4:2:1 resonance, so Io zips around 4 times for every 2 laps by Europa and 1 by Ganymede. Io's volcanic eruptions spew charged particles that get trapped in the magnetic fields between moon and planet, lighting up Jupiter's poles with constant, powerful auroras. Beneath those swirling clouds, Jupiter's atmosphere is a mix of hydrogen, helium, methane, and traces of other compounds. The lighter hydrogen and helium rise, cool off, then sink again, fueling the massive convection currents that drive the planet's storms, including our iconic Great Red Spot. Now remember that core? Jupiter's interior is almost as hot as the sun, and it's mostly hydrogen and helium, just like our star. But here's a fun fact. If Jupiter had somehow gathered about 80 times its current mass, it might have ignited into a star. To become even a brown dwarf, a failed star, it would need about 13 times more mass than it has now. Not even gobbling up all the asteroids in the belt between Mars and itself would be enough. So the idea of Jupiter as a failed star is really just a myth. Thanks to James Webb, we're finally clearing up these misconceptions. And that's what science is all about. It's driven by one simple human emotion: curiosity. For years we've pointed telescopes at Jupiter, but only in the last few months, with a brand new telescope, have we started to peel back so many layers of mystery. Now it's your turn. Imagine you had the control to the James Webb Space Telescope. What mystery would you unlock first? Drop your wildest ideas in the comments below and let's spark a conversation. And don't forget to subscribe and hit the bell so you never miss an episode of SpaceTube. We've got mind-blowing discoveries lined up, and I want you back for every one of them. Thanks for watching, friends. Stay curious, keep exploring, and I'll catch you in the next video.